So for question 7, we're going to use a useful formula. It's a formula that the general and further maths students should be really familiar with. So the value of an investment which earns compound interest can be calculated from this particular formula. P is the initial investment, R is the interest rate per annum, N is the number of times per year the interest is compounded, and T is the number of years of the investment. Ali, that's really annoying. Yeah. Sorry. An investor deposits $2,000 into an account where the interest is compounded monthly. If the interest rate is 3% per annum, we're asked to show that the formula can be given by A equals 2,000 times 1.0025 to the power of 12t. So if we write a little list of the things that we know, so we're given that the principal value, the initial investment, is $2,000. We are also given that the interest rate is 3%, which can also be written as a decimal, 0.03. And we're told that the number of compounding, or the compounding period, is a month. So therefore, in 1 year, there are 12 compounding periods. So n equals 12. If we substitute those into the formula, we end up with A equals 2,000 times 1 plus 0.03 over 12 to the power of 12t. If we evaluate that expression that's inside the brackets, we just get 2,000 equals 1.0025 to the power of 12t. And that's what they asked us to prove. The next part of that question is to calculate how much the investment is worth after a 6-month period. Now be careful here, because 6 months is half a year, and we are using units that are in years. So if we substitute half, t equals a half, into the formula that we've just derived, twelve times a half is just 6, and we can put that straight into our CAS. And we get $2,030.19. The third part of the question, what is the time period, so what time period would be needed for the value of the investment to reach 2,500? So this time we let A equal 2,500 and we find T. So we have 2,500 equals 2,000 times 1.0025 to the power of 12t. And I would put that straight in my CAS. Solve. 2,500 equals 2,000. Straight in my CAS. And I would find that t equals 7.4 years. For part B, we're going to reverse engineer the question. The investor would like the $2,000 to grow to $2,500 in a shorter time period. Now we're asked to find what the interest rate should be if it's still compounding monthly, if we want to achieve this particular goal in 4 years. So again, let's write what we're given. We're given that the amount at the end of the investment needs to be $2,500. The initial amount is still $2,500. The number of compounding periods is still 12 months in a year. The time we wish to invest for is 4 years. And we want to know what the interest rate is that we should aim to invest with. So we're going to use this formula again. So substituting the values in, have 2,500 equals 2,000, 1 plus our r, which is unknown, divided by 12, and it's 12 times 4. So I put that again straight into CAS. And you will find that you in fact get 2 values for r. So I might do that so you see what happens. Oops. I've got approximate solution. So I get 2 values for r. So those values are r equals minus 24 and r equals 0.056. Now we're going to reject the negative values. No negative interest rate. It's also really large because that's thousands of percent. So we want this one here. So in other words, our answer is r equals 5.6%.